Greetings everyone, this is Puya. So today we're gonna see a little bit more about solar panels and especially the application of power electronics in controlling solar panels efficiency. And we're gonna talk about a method called, or a technique called maximum power point tracking. Before I start talking about Mppt, I want to remind you that in the previous session, we saw a little bit about solar cells and how solar cells are basically converting solar energy into electricity. Wanted to mention that one solar cell, like itself, it doesn't have that much power. So what we do, we saw that like we put many of these solar cells into series together, or like in a combination of parallel and series topologies together to get solar modules or solar panels. And also in solar power plants, they put many of these solar modules together to put a solar array. So when we talk about modules or panels or arrays or cells, this is basically what they look like. So if you have a solar, let's say like a solar cell, if you put multiple of them, let me just like show, for example, this is like, you put multiple of them together, then you get a solar module. And if I show a solar panel like this, if you put multiple of them together, you basically end up with a solar array. So when we talk about solar cell, solar panel, solar module, solar array, this is what I mean. Now, the next thing I want to talk about is one of the important characteristic of solar cells, solar panel, solar modules. Let's start with solar cell. We want to talk about the IV characteristic of a solar cell. IV characteristic. So when we talk about IV characteristic, I'm gonna focus on IV characteristic of a solar cell, but it's gonna be almost the same for solar panels and solar arrays. So as you saw previously, a solar cell has a P and an N junction. So we would have, and it has a depletion region here. And if I want to be more accurate, the N region is a little bit thinner to make a depletion region a little bit wider, and also like make the solar radiation go through the depletion region faster or more efficiently. So we saw that we would have electron hole couples, and that's basically how we can generate electricity. That's how electrons basically move towards the P region. So this is very similar to a PN junction that we've seen in the diode, right? So we can model a solar cell with a diode. And if you remember, the IV characteristic of a diode is similar to this, right? It's an exponential curve. Sometimes when we talk about the ideal diode, we show it like this or like this, but this is the actual IV characteristic of a diode. Now, imagine that we also have let me show it like this. imagine that we have a current source, which is basically the radiation from solar panel. So this is basically creating couples of holes and electrons, and it goes through the goes through our solar cell, and this is basically a more realistic model of a solar cell. So, and we would have a load here. Okay, so if I combine the characteristic of the diode and the current source, that this is due to the radiation, and let me just call it IR. In textbooks it's called IRR, but this is basically a quantity that we talk about in solar cell studies is irradiance. I just want to make sure that I spell it right, irradiance. So this is how much solar energy you receive per an square meter of area, an area of a square meter. So this is basically modeling the irradiance of the solar cell. And if we combine these two together, so the characteristic of a constant current source and the diode, and we also have a load. So the IV characteristic of a solar cell would look something like this. So this is called voltage, open source voltage. This is called short circuit current. The open circuit voltage is when you have a solar cell and in perfect condition you measure the terminal voltage of the the solar cell. That's the open circuit you get. And the short circuit, it basically means that if you make this one short, how much current goes through it. And this is a characteristic of a typical solar cell. It looks like this. Before I go any further, I want to mention that we categorize solar cell based on their nominal voltage. That nominal voltage is different from the open circuit. That nominal voltage is somewhere in this range. It's before the open circuit voltage. So don't confuse nominal voltage with open circuit voltage. The nominal voltage is basically a way to categorize different solar cells. Now, this IV characteristic